Okay, thank you. Thank you, Peter. With reference to obliteration on my title, can I ask for a show of hands? Who knows what OBI means? No? Okay, what if I spell it out? Obliteration by incorporation. Who knows what obliteration by incorporation means? Okay, this is going to be fun. So as you may have heard, I was the first hire for the FM Kirby Research Center for Functional Brain Imaging because these two gentlemen were already at Johns Hopkins. But I don't think that's why I'm the first speaker in this session. I think I'm the first speaker in this session because of my visible light formation over the years involving photographic imagery at the Kirby Center. I don't want you to think a lot of it involves a cake, to be clear, but some of the images have no cake. And some of the images even happen further afield. Of course, there are the requisite magnet delivery photos. This one demonstrating the foundational nature of the 7T. Look, the glazing in the building isn't finished. This is how you start a building. You put the magnet in the basement. Here for at least the first year or two, we must have been good because Santa brought us this 3T magnet. And when the first magnet was delivered, this was a sign of celestial blessing, right? This is not Photoshop. This is a sunbeam shining on our magnet delivery. Oh, I'm sorry, I don't know how this one got in there. But when I look through my photos of Kirby Center people having a good time, what I notice is so many of them happened during the annual research retreat of the Division of Magnetic Resonance Research. So this division, now led by Professor Peter Barker, was led for most of my time here by Professor Paul Bottomley. And when I look at the division retreat photographs, what I see is always Professor Bottomley with his hairball. So there's the hairball slide in 2011, and there's the hairball slide the following year. And courtesy of Paul, here's the hairball slide. And this is meant to demonstrate that so much of science happens in this known region in the middle. You know, let's sequence another gene, let's find the structure of another protein. Well, the pioneering work is the work that provides new ways to do things, new things that can be done. And again, courtesy of Paul, this is an idea of what some new threads on the hairball were, diffusion MRI, in vivo MRS. We were so smitten with this analogy, with this metaphor, that we made it real. This is the golden hairball, the trophy of the Division of MR Research that circulates, that stays each year in the lab that won it the last time. And every year at the division retreat, there's a vote at the end of every session. Who gave the talk, not with the best slides, not the best talk, but the talk that looked most likely to lead to a new hair on the hairball? At the close of the retreat, the hairball would be awarded, and depending on the degree of enthusiasm, it could be chest high or head high or well over the head high. So now after 25 years, if we ask, have we grown any new hairs on the hairball? I think the answer has got to be yeah. First fiber tracking paper, thousands of citations. First group ICA paper, thousands of citations. APT, amide protein transfer, assessed MRI, over 1,000. APT for tumors, almost 1,000. Vaso fMRI, more than 500. Trust for looking at brain physiology, hundreds there. Probabilistic tractography, more than 1,000, and anatomically motivated reduction of motion artifacts in resting state fMRI. But I think there's something more to this story. If we look at this Vaso paper, 500 citations may seem like a lot, unless you go to the ISMRM and they got whole Vaso sessions, and there are Vaso issues of journals. So what's going on here? If we do a Google Scholar search for Vaso fMRI, we find more than an order of magnitude more papers on Vaso fMRI than there were citations to that founding paper. So what's going on here is called obliteration by incorporation. This is a term in the sociology of science that refers to a stage when certain ideas become so universally accepted that they're just part of the field, man. You don't need to cite them. Like when you write about DNA, you don't need to cite Watson and Crick. So again, Vaso has more than an order of magnitude more, papers using Vaso fMRI than citing that first paper. APT, CEST has 50,000 citations, Group ICA more than 70,000 citations, fiber tracking more than 70,000. And this is not counting those papers that surely exist that use these approaches that don't even, use them as keywords. So this is the way to know when you've grown a new hair on the hairball, is when you're not cited, right? When you're only cited thousands of times, but when tens of thousands of papers are using these approaches. So why are we here today? We're not here just to make us old people feel good about growing the hairball. We're here because we are convinced that the young people are going to do even more and even better. But what is the biggest obstacle to growing this hairball? What is the biggest obstacle to developing new technology? And the greatest obstacle is not ignorance, it is the illusion of knowledge. So Daniel Boorstin made this comment about the age of exploration, about sending ships to discover new lands. The greatest obstacle wasn't not knowing what was out there, but was a false belief that everything was known. In short, the idea that the hairball is so big that there's nothing really outside, that there's nothing new to do. But I want to tell you that the hairball is really small, man, okay? And this isn't a new idea. Look, Max Planck was advised not to go into theoretical physics because it was a highly developed, nearly fully matured science. That's what his professor told him. Fortunately, he didn't listen to his professor, and 40 years later, he won the Nobel Prize in Physics for the quantum theory. So sometimes I think that, as the author of The Princess Bride put it, nobody knows anything. Now, my wife is here, and she can confirm for you that last month she was out of town. She called me on the phone. She said, "How is everything?" Well, I said, everything is mostly only inferred and not understood. You see, because I've been reading about dark matter. And if you think that physics is approximately what stuff is and how it works, and cosmology, which is part of physics, one thing cosmologists do is they look at how big old things like galaxies, move in order to figure out what else is there. And NASA has this great web resource for kids, and they explain stuff. What is dark matter? Dark matter is stuff that has gravity but is invisible and isn't like anything else we know about. So dark matter and dark energy combined make up more than 95% of the universe. So you think physicists know what they're doing. You think physicists understand what stuff is and how it works, but they really only understand less than 5% of it. So what is the dark matter of the brain? I don't know. Is the dark matter of the brain consciousness? Is the dark matter of the brain how general anesthesia works? Is the dark matter of the brain maybe preventing childhood tumors, preventing childhood epilepsy? I don't know, but what I do know is that I'm speaking to the young people here, to the trainees here, that you will find out, that you will grow the hairball, and that you will pass on this hairball. So thank you very much.